There's nothing that anyone can do to stop this revolution from being delivered to people's hands.
So Dan, I have an interesting question for you. You mentioned yesterday that creating meaningful assets is really one of the value propositions for the TODA protocol. Can you elaborate a little bit on that one? You mentioned about how it's going to shift loyalty, points, health records, that sort of thing.
Sure, yeah. If we think about what digital assets are currently, how those are expressed, what it means to own a digital asset. So owning, we're in Toronto, owning an Aeroplan mile or an Optimum point or something, or a video game asset, right? What does my ownership of that actually mean? And how is that different than owning a physical asset, my phone or something? And what would it mean to have meaningful digital assets? So these are some questions that we can ask about this space. What does it mean to own Aeroplan miles right now? It means that there's a row in a corporate database somewhere that's associated with my user account, and then it says, here's an asset, here's the association with me, with Dan. And this is not actually a very good expression of ownership, because it means that I don't actually have possession of that at all. Instead, the source of truth about that asset is always in that corporate database. So that means that corporation allows me to use that asset as long as they still like me, and as long as they are still solvent, and as long as their database hasn't been corrupted, etc. If they ever go out of business, it's gone. If they ever stop liking me, they can take it away whenever they want. If their data is compromised or corrupted, it's gone. Additionally, I don't have any of the agency with respect to that asset that I do with a physical asset. So, with my phone, I can give this to you, I could lend it to you, I could sell it to you, I could rent it to you. I can do all kinds of things with a physical asset that I can't do with a digital asset because I don't actually own it. I don't have any possession of it. The things that we own are increasingly digital. Books, movies, music, all of these things, right?
But they're dependent
More and more, they're
on...
becoming digital things that we own, except we don't really own them. We don't have a good story about ownership of digital assets right now, of any kind. I don't own my health record. I don't own any of these things. So what would it mean for me to be able to own these things? Right? My health record is fractured among dozens of different corporate silos that are competing against each other to hold that information as tightly as they can. That's their source of value. They don't want to let that out. So what would it mean for me to own these things?
How would that actually look like with the TODA protocol? And how does that actually shift? Because you mentioned that TODA in itself is a paradigm shift, and it's changing the way we look at digital assets, that each token, so to speak, would actually represent a very unique asset, unique attributes. And is it only on, say, a mobile device or a piece of hardware where we would actually start thinking about how we would own our own assets?
Well, one thing that we could ask is, what would it look like for that corporation to give me that Aeroplan mile right now? So they could give it to me right now, but then of course I could make 1 million copies of that because it's just information. They're thinking of that digital asset as being information. That's all it is. So when they give it to me, I just have information, and you can always copy information. There's no way around that. So I could make 1 million copies of this and come back to them and say, hey, I've got 1 million Aeroplan miles, fly me around the world, right? What keeps me from being able to do that is simply that they hold the source of truth of that asset. And if they give it to me, they still need to hold the source of truth. They have a registry somewhere, a ledger somewhere, that says we gave Dan 1 Aeroplan mile. And if I come back with 1 million, they go and look at the source of truth and say, oh, we only gave you 1. You can't have 1 million. That doesn't make any sense, right? They have to do that to protect themselves because that asset is just information. We need a way of having digital assets that are more than just information. If I give you a book and I say, here, copy this book for me, what do? You get a blank book, and you copy out all the information in this book into this book. Of course, we can have millions of copies of books that have the same information in them, but each of those books is a unique thing in the physical universe. If I give you a book and I actually want you to make me a second physical copy out of it, this is nonsense, right? It's so much nonsense that it's actually hard to describe what I want you to do, right? And so what we need is a way of saying, okay, this part of the digital asset is information, sure, but there is another part, this is what TODA provides, And that other part functions in the same way that a physical book functions. It gives you absolute uniqueness within this universe of assets. And so that asset, that binding of the information into the digital asset, is guaranteed to be unique inside of this universe of digital assets. It can never be copied. It can never be duplicated. It is unique.
Is it something?
And that's what TODA provides.
Who defines the attributes then?
The attributes are just information. And whoever creates that digital asset defines that information. Just like whoever prints the book defines what is printed inside the book.
And I think what you're asking, who defines the actual global universal uniqueness?
Yes.
So what TODA relies on is a data structure, using something that every computer scientist is familiar with. It's called a binary tree.
Okay.
And a specific form of binary tree is called binary search tree that is fully saturated and complete. If it has any computer scientist that is listening, or anyone who doesn't even know binary trees, they can search on Google or Yandex or Bing or Alibaba binary trees.
A9.com.
Huh?
A9.com.
Yeah, that's right.
I'm trying to
But
bring that back.
you find out
It's
what's a
not
binary tree, and then you'll be able to imagine if that binary tree has 256 levels. It's easy to imagine, yet a binary search tree that is fully saturated and complete, it's easy for any computer from the 70s to traverse it. However, it's impossible for all computers on the planet to ever create this entire tree, because on level 160, it can have more points in it than the estimated atoms in the universe. So it has a lot of points. So that data structure, think about it as if it's like the imagination for all computers that they can rely on when they are working with each other. When one computer resides on that tree, the packets of that they belong to that computer, they also reside on the tree. Any computer can create any packets and pretend to be fakers, but there's something that is super cool that happens with TODA. There's a single thing that is global, that is replicated in every single device. And when we called it the actual Merkle root, some people, they got upset because it doesn't resemble the centralized built Merkle tree. So the TODA, the way it builds the actual Merkle tree, is in a decentralized distributed setting where each and every device is responsible of contributing distributed computing in a deterministic way in order to contribute the building of that Merkle tree. So if folks are going to call it TODA Merkle, T Merkle, we insist on keeping the word Merkle because we like to give credit for the initial inventor, or Ralph Merkle in the 70s invented the Merkle tree. So that tree, what happens that, so let's say in Bitcoin on TODA, Satoshis, they're the smallest unit of Bitcoin. Every 100 million Satoshis equal to 1 Bitcoin. So if you imagine that you have some Satoshi sitting on your device, you want to transfer them to Jan or to Edward. When you are going to send, you can fake and send millions of copies of each and every one of Satoshis to a lot of people across the planet. But the ownership of each and every Satoshi in that tree at any block of time can only be to a single device in that tree. It cannot coexist. So effectively, in every minute, which is the block time of TODA, you get the finality after 1 minute when you transfer it from your device to someone else. You take that Satoshi, the packet, from your device, and you're sending it to someone else. What happens in that global thing is that the hash of that transaction is concatenated with another hash of another transaction that happens around the same time, and that's called temporal coupling. And then it keeps going up to 51 levels, because 2 to the power 51 equal all the Satoshis that can ever be created in a 21 million Bitcoins. Once you get to level 51, or once other devices that they're contributing into the computation of this, they get to level 51, they get to the hash of the block, which is the Merkle root. And that hash is the one that is replicated through every single device. Why is that so important? Because if you send that transaction to Edward, and Edward wants to send it to Bob 6 months from now, look at the time, and it says it's like 2:07 p.m. California time, PST. at this specific time, everybody has that exact same hash on the planet. So 6 months from now, Alice and Bob, they both have that hash in their device. So if Edward decides to send to either Alex or to Bob, what he had received from you is what contributed to the creation of that hash. See, he couldn't even fake it and say, hey, I wanted it. He could fake something else, they will know instantaneously. Like, it's not part of that hash that I have in my wallet. So that is super powerful, that it's actually taking, when we say the modification of TCP/IP, we're not doing magic, we're literally using a lot of the learning and methodologies being used for the last 43 years and putting them all together to create what is called TODA, which include data structure, like I've mentioned, algorithms of how the actual tree is being built, deterministic algorithms, which is basically distributed computing, have cryptography, we have what folks call cryptoeconomics. This is a new term invented. Some people don't like it, so we don't necessarily want to be stuck on that. But it's essential to have certain things that of value when you're in Bitcoin. For example, you have to consume certain resources, and with the TODA, when you're actually putting Bitcoin on TODA, there is no free lunch. So the 12.5 Bitcoins that gets printed every 10 minutes. Today they go to a single miner, but imagine those they're going to 10 million users. If they're spread out through all the 10 million users, and each and every user they're taking a small piece of that, each and every user they have the incentive to continue keeping their device on, be part of the system. Otherwise, people they lose the incentive to be part of this. There's some replication in the work that is being done in TODA. So the single replicated thing that is global is that Merkle root. But replication of work is an x32, so it's about 32 times. And the reason for that is because if you're sending a transaction, there's 32 devices available that they are selected deterministically and pseudo-randomly. If one is off, the other one has a very high chance to be on. You just need one of them to be on to kind of take your packet and build it through the next level. So you will have basically in 51 steps in Bitcoin, for example, you end up with 1 in 4 billion chance of not finding, not getting your packet to make it across, but that doesn't mean that you're losing it. It stays in your device. The finality happens after 1 minute regardless, whether the packet you've made it to be transferred or not. It's relevant, but it's not relevant in the sense that you're going to lose it. You won't lose the packets. In TODA, the packets, they're there. There's nothing going to be lost. That's reality. Finality happens in 1 minute.
So TODA is basically, it's a zero-level protocol for a blockchain versus a cryptocurrency. I was wondering if you could just sort of like elaborate on that.
So yeah, we decided not to call it necessarily a zero-level protocol because when folks looked at TODA and they saw it basically, this is exactly what they said to us. So it's a zero-level protocol. So we're like, that sounds cool, so start calling zero-level protocol. And then again, we found that over 50 ICOs, they're calling themselves zero-level protocol. So we got into this whole thing where it's like, why do we want to call it zero-level protocol initially? And we know they're lying. We know for sure they're lying. They're not even on the same level of TODA.
Okay.
But we want to be telling the truth. And in the network topology, TCP/IP is on level 4 and 3. So why are we going to be, suddenly it's like 0. So we understand it's like, layer 1 is considered Bitcoin, Ethereum, whatnot. But in reality, they're above layer 5, 6, 7. So from that perspective, we decided not to call it that. If folks want to call it the invisible layer, that sounds cool too,
Yeah, because the 7 layers of the internet is a little confusing when you bring in Bitcoin and all that.
That's right. That's what people they call, for example, Lightning Network and layer 2 and state channel. It's over on the second layer, but it's not really second layer. So that's fine. They can call whatever they want. We decided to not necessarily call it layer 0 because of the 50 scammy ICOs, or some of them they're not scammy, but they just decided to call it layer 0.
The positioning there was always about finding a way to highlight the fact that TODA does something that is more primitive than a ledger. And so if you want the functionality of a ledger, you need to build back up to that from TODA. So you build decentralized protocols on top of TODA that get you back up to the power of a ledger. So that for those use cases where you need a global public ledger, you have that. But underneath it, you can make use of more efficient things if you don't need the full power of a global public ledger. So it's doing this in the opposite order. It's saying, look, here's the base layer. It does the most primitive thing. All it does is give you meaningful digital assets. It doesn't give you any of the stuff that a ledger gives you. It just gives you this. And then you can build up from that to get something like a ledger. A ledger is always going to be expensive. A global public ledger will always be costly. Even if you ignore the consensus cost, you've still got network costs. You have to tell everyone that you've done something. The point of a global public ledger is to have a place where anyone can write, everybody reads, and it's tamper-proof. So if everybody's reading your transaction, if you have to tell everyone in the world that you've bought a cup of coffee, that's going to be expensive. It's going to cost more than the cup of coffee.
But
You've got
that's
storage cost, you've got compute cost, even if you ignore consensus. Global public ledgers are always expensive, but if you need one, then you should be able to use it.
Yeah, and the other thing is, you discussed this too when you were talking to the people at the hackathon, and that's about the protocol standards. And you're partnered with some of them, and I was wondering if you could kind of outline some of them and how that is working in the ecosystem and the development.
Yeah, so a lot of that work is really about taking the efficiencies that we have with the TODA protocol, where it's positioned right now, and making it even more efficient. We're a bit radical about efficiency. So then there's this question of how can we take this protocol that's running kind of at the software layer and push it down further? How can we push it into the hardware layer? How can we push it into the network stack? How can we actually push it all the way down into this OSI model that we mentioned, this network layer model? And so this is a lot of the work actually that Toufi's been doing with kind of V2 of the protocol, talking to the ITU and a whole bunch of other organizations and actually moving forward with their standards bodies to get that pushed down.
So how receptive are they? These standards, these organizations that set these standards?
Not super receptive initially. Initially, many of those standard bodies, they're used to hear from Cisco when they need something, not from like a startup. And when they do hear from startup, especially in the crypto space, what you find in that crypto space, and a lot of people, they keep stabbing each other in the back and stealing from each other and so on and so forth. So, and sometimes because they're upset because their ego is hurt because they thought that the current solution they're working on is the one that's going to work, which is ledger-based. It's not going to work. Ledger-based is not going to make it to be the whole revolutionary thing that people talk about it. So we know we have a solution that can work, but when we sit down with the standard bodies, we feel that we were making some progress with some of them. If I tell you with all of them, I'd be super optimistic, but we continue trying with all of them. We don't exclude any one of them.
So I think you listed three. Can you just list them all?
Oh, we listed like for example, the ITU, the ISO, the ACM, IEEE, IETF. Those are 5 very well known, but
Which are the most important ones, do you feel?
well, I don't know yet, but I can tell you that even with or without them, here's the thing: for those that they keep attacking us from within, or trying to call the big kahunas in those companies or whatnot, or trying to discredit something that's being provided to Homo sapiens, I'd like to leave you with this. There's nothing that anybody can do to stop TODA from being put into people's hands. Nothing. What's been done already so far, we've already given it to enough people that even if this is the last time Dan and I were talking to people, they shoot us in the head, what already we've given to people, it is going to make it. It's a set of instructions that's fully decentralized, that people, they take those instructions like language. Once you learn a language and you can communicate with Lori, nobody can take that language away from you. The settings that we're giving, they're fully decentralized. There's no dependency on miners, no dependency on specific network. There's not a single dependency. So eventually, we're giving it to the people, and eventually people are going to get it. And people, they are going to have full control of their own assets. And the remaining 99.8% of the planet, they are going to get there. So what you have seen so far, the people, they got the FOMO effect last year, that's been a tiny little wave. What's yet to come is a tsunami. So for folks that they want to continue blocking that tsunami to happen, they're the ones that are going to be impacted the most, because if you block the tsunami, instead, perhaps people, they can participate into making it happen to be a better place for everyone on this planet, that we can remove a lot of those inefficiencies and get to prosperity sooner rather than later globally. So,
what are the next steps for TODA Network?
So distribution, so this, we're doing a lot of distribution with a lot of folks. Like we're super excited about Ethereum on TODA. We doing a lot of progress with the folks, the Bitcoin, which I cannot talk on their behalf. Bitcoin is for everyone on the planet. We've already had 2 passionate developers for the last 9 months. There are 2 others that they reached out over the last few weeks. They also started work separate, and they're happy not to collaborate. That's fine with the other folks. But from our perspective, we're giving it to everyone on the planet. We don't have restrictions. We say that, for example, Ethereum on TODA is the killer of all Ethereum killers, including EOS. But I can tell you with certainty that if folks in EOS, they have a little bit of less of ego and more of, they're truly looking to something revolutionary and they want to make it happen, we'd be more than happy to talk to them. In fact, I'm talking to one of them right now that could get something going as well. So yeah, nothing's going to stop TODA. It's going to make it there. People could delay it a bit, but not by much anymore. What's been out, it's just, it's not if, it's when. If you know when the tsunami is coming, you could run away, or you could participate in making it happen. It's up to you. But you can't stop a tsunami from happening.
So I'm sure there's going to be lots of questions following this interview. How do people get in touch with you guys or follow you? I mean, you've done incredible work so far. I expect some great things in 2019.
So the one thing I would really ask, please, for folks, I receive about 5,000 messages per day addressed specifically to me, like literally addressed to me. It's not, and I think I'm still a Homo sapien. And I don't think Homo sapiens are capable of addressing 5,000 messages. So I end up ignoring a lot of messages. Not that I don't want to ignore them. I can't respond to everyone as much as I'd like to. So I just simply tell folks, like, we don't take care of anything that it's like solicitation of marketing anyways in our company. We already have people taking care of those things. From our perspective, what we respond to is somebody who wants to help truly deploying the protocol somewhere. They really want to move their company into the TODA. They have some investment they're about to lose in some company. They want to convince their CTO to be moved on. They want to invest in some of those companies' ecosystem because they like Ethereum on TODA or they like any one of those. We're more than happy to facilitate those kind of things, but we can't, respond to everyone. So I would perhaps, if it's any one of those, go to TODA.network. That's the website, and send a request. I have heard Toufi saying that he would respond to one of those. The people would see it. They will make sure I get it, and 100% guarantee that they respond if I'm not dead by then. So then, how would you like them to reach out to you?
Sure.
Same? Same?
Are you on Twitter?
I am on Twitter, yeah.
You are?
It's just my name, Dann.
That's it?
That's it?
That's why I couldn't find it.
Yeah, it's too short. No. It's just I'm just Dann.
And Toufi, I know you're going to be leaving. It's just after 5 now.
Mm-hmm.
And I just quick question about the hackathon. That was really cool that you were addressing just before they started. You had 2 challenges, and so that's one question I have. Just quickly, if you go over that.
Sure.
And the other question is, I understand that you released some to some people here. Access to your protocol to test it or something like that?
Oh, sure. Okay.
So if you could address those.
Absolutely. So Like I said, given that we're monetizing and what we know, the rest of the world don't know or still skeptical, we don't have the incentive to convince people that it works. But yet, we decided yesterday to share version 2.11, a summary, which is I wrote it myself, then reviewed it. It's not it's not written in a way that it's going to be scientific, to be criticized as a scientific paper. It's not written to be a scammy ICO or anything like that. It's not one of those white papers. It's a true white paper that we've tested it before giving it to developers, and they're able to build using that. Along with some questions, sometimes they come. Now we've shared this. We've also, some of the developers they're building on TODA in this hackathon, they asked for one of the APIs that we have with one of the implementations. And then it's facilitated that as well. So those are two things that happen. And I know you wanted to mention, this is the Block Hack. It's the second hackathon that happens here in Toronto for Block Hack. It's organized by Bitcoin Bay, a fascinating community. We stand behind these guys. And a lot of the guys across the globe, the Bitcoin Center in Korea and the folks in San Francisco, doing phenomenal work to benefit everyone on the planet. The majority of people that we know in this space, whether it is Toronto, Korea, or San Francisco, are very well intended. We want to make sure that they can deliver on the promises that they have and intend to deliver. So yeah, this hackathon is exciting, and yeah, I would say Toronto, it's probably on the top 5 globally when it comes to this industry. I'm not here to rank it number 1 or number 4, 3, whatever. But it's likely to be on the top 5. If you know, I would say Toronto, San Francisco Bay Area, and Seoul, Korea. Those 3 probably on the top 5. Which ones are the other 2? Let them have that debate elsewhere, whether it's Berlin and Shanghai or you know.
I think that's a wrap.
Yeah.
Great.
Did you guys want any last words?
I'd like to reiterate: there's nothing that anyone can do to stop this revolution from being delivered to people's hands. What we are giving the world is a set of instructions, that those instructions will make it whether we live or not. And those instructions, they're basically any device. You change the operating system, people get a new one. You block them from the network, they get to a mesh network. This is becoming eventual, and it's going to happen. And we're super excited to bring it to the world and to everyone in the community. And thank you for having us.
Thanks.
Thanks so much for your time.
Thank you.